Hi, welcome to Physics Teacher, the channel that prepares you for the Waterloo Math and Science Contest. This is a grade 10 Math Galois contest question. It's question 3 from 2021. There's 3 parts to this question. All parts have to do with this rectangle ABCD, which has the following vertices. And we culminate in part C, which says that this line that passes through point U, which we don't know, and W, which we don't know, and V, which we do know, divides this rectangle into 2 trapezoids, and we need to determine all the possible pairs for U and W for which the ratio of the areas of these 2 trapezoids will be 5:3. Give the 3 questions a try. You can skip to the solutions of each one in the chapters menu below on the timeline, or you can wait a few seconds and I'll be right back with the solution for part A. Alright, so part A says that these diagonals AC and BD, like so, intersect at point E. So let's call this point E. What is the area of ADE? So this triangle in here. So first we can figure out what the point E is. Since it is the intersection of these 2 lines, it is going to be the midpoint. Now since it's the midpoint, its x-coordinate is going to be right in between 0 and 6, which will be 3, and the y-coordinate will be between 0 and 12, which is 6. So there's the coordinates for E. And so now we can find the area of the triangle ADE, which for a triangle is just 1/2 times the base, which is 6, times the height, which is also 6. So 6 times 6 is 36, multiplied by 1/2 gives us an area of 18. Alright, let's move on to part B. Now part B says there's a point P at the coordinates 0 and P. So somewhere on this line between A and B is a point P. Let's say here, for example. And the area of the trapezoid BCDP, so it would be B, C, D, and P, is twice the area of this triangle over here. What is the value of P? Well, we can first look at the area of this entire rectangle. So the area of the entire rectangle ABCD is just going to be length times width, which is 6 times 12. So that is equal to 72. Now, since the area of this trapezoid is twice the area of this triangle, we can say the area of the trapezoid is 2/3 the area of the entire rectangle, and the area of the triangle would be 1/3 the area of the entire rectangle. So if the area of the triangle is, for APD, is 1/3 the area of the rectangle, that's 1/3 of 72, which is equal to 24. So since we know what this area is then, we can set that area equal to, well, the area of a triangle is 1/2 the base, which is 6, times the height, which is the value P that we're looking for. So that's going to be 24 equals 1/2 times 6 is 3, P, divide both sides by 3, and we get 8 equals to P. So our coordinate for P will be 0 and 8. Alright, so part C. So in part C we have this line. It's already drawn for us, where it passes through U with the coordinates 0 and U, and W with the coordinate 6W. And it goes through the point V, which we know has the coordinates 2, 4. And so we actually have 2 cases. The first case is this one that I've drawn here. already, so that's case 1. So starting with case 1, so we have two trapezoids, one below the line and one above the line. Now because it says the two trapezoids have areas with a ratio of 5:3, that means one of them has an area of 5/8, the total area of that rectangle, and the other one has an area of 3/8, the total area of this rectangle. Now we can also find the slope of this line that separates those two trapezoids. So u has the coordinates 0u. So that's going to be the difference in our y coordinates, which is 4 minus u, divided by the difference in our x coordinates, which is 2 minus 0. Now I can also take the point w, which is 6w, and find the slope by using the points v and w. Now the slope will be the same because all these points are on the same line. So if I do that, we use our y coordinates, so w minus 4, and the difference between our x coordinates, 6 minus 2. Alright, so I'm going to rearrange this a bit. 6 minus 2 is 4, and multiplying, we get 4 times 4 minus u equals, multiply the 2, we get 2 times w minus 4. So let's distribute, we have 16 minus 4u equals 2w minus 8. So we can divide everything by 2. So we'll have 8 minus 2u equals w minus 4. Or solving for w, we get w equals to 12 minus 2u. Alright, so I'm going to write this equation here, and we're going to save it for later. Okay, so let's focus on this trapezoid UADW. Now since it's going to be 3/8 of the entire rectangle, and we found in a previous question the area of the entire rectangle is 72, the area of that trapezoid is going to equal 3/8 of 72, which is 27. Now I also know the area of a trapezoid is simply the base, AD, which we know is 6, times the sum of the two sides, which would be u plus w, all over 2. And that's going to equal then 27. Now, since I know that w is 12 minus 2u, I can replace w in this equation. So 6 times u plus 12 minus 2u all over 2. We can bring the 2 out on this side. Is equal to 27. Or 3 times 6 over 2 is 3. U minus 2u is just negative u plus 12 is equal to 27. Alright, dividing both sides by 3 gives us minus u plus 12 is equal to 9. And therefore, if we solve for u, we'll see that u is equal to 3. And plugging 3 back into this equation, we get w is equal to 12 minus 2 times 3, which is 6. So 12 minus 6 is 6. Alright, now this isn't the only case or only values for u and v which will satisfy this condition. There's another case where this can happen. And that's if u and w go beyond our rectangle. So if we were to have u somewhere down here, beyond our rectangle, and w somewhere all the way up here, and we connected these lines through v, we still create these two trapezoids. And you can see them here. Now the ratios are going to be the same, so our smaller trapezoid will be 3/8 the area of the total rectangle, and the larger one would be 5/8 of the total rectangle, to make sure that this ratio is still valid. Alright, so what we're going to need in order to solve this problem is we're going to need to know these 2 points where this line actually intersects our rectangle. So let's call this point E and this point F. And F will have the coordinates F and 12, and E will have the coordinates E and 0. So now we're going to do what we did before. We're going to find the slope of this line using our coordinates for V, which is 2 and 4, and E and F. So let's start with the slope using E and V. So finding the difference in our y coordinates, we have 4 minus 0, divided by the difference in our x, which is 2 minus E. And that's going to be equal to the slope VF. So we have difference in y, which is 12 minus 4, over the difference in x, which is f minus 2. Alright, so to make this a little easier, I'm going to take the reciprocal of both sides. So we'll have 2 minus e over 4 equals f minus 2 over, and 12 minus 4 is 8. So then we can cross multiply, so we have 8 times 2 minus e equals 4 times f minus 2. And if we divide both sides by 4, we get this. Distributing the 2, we have 4 minus 2e equals f minus 2. Or solving for f, we get f is equal to 6 minus 2e. Alright, so let me write that equation on the side so we can use it for later. Alright, so the area of this smaller trapezoid, which is 3/8 of 72, just as before, will be an area of 27. And then the area of that trapezoid is simply the base, which is right here. So that's going to be 12 times the average of the sum of the sides. So this side will be f, the other side will be e, all divided by 2. So now I can replace f with that equation we got from the slopes, which is 6 minus 2e, and then we still have that plus e, and this 2 we can bring out here to make things easier. So that gives us 6 all times by 6 minus e. So we have 27 is equal to 36 minus 6e, or rearranging, we got 6e is equal to 9, or e is equal to 3 over 2. Knowing that e is 3 over 2, we can substitute that into this equation, and we get f is equal to 6 minus 2 times 3 over 2, which is the 2's cancels, and we get 6 minus 3 is 3. Alright, so now that I know what these coordinates are, where f is going to be 3 and 12, and e is going to be 3/2 and 0, we still need to go back and figure out what the coordinates of u and w are, as that is what the question is asking us, not what e and f is. So first, let's use the actual coordinates e and f to figure out the value of the slope. So the slope, well, m, is equal to, again, difference in our y coordinates, so our rise, which is 12 minus 0, which is just 12, divided by our run, which is 3 minus 3/2, which gives us a slope of 8. So now that we know what the slope is, we can figure out what the coordinates u and v are. So we're going to go back to u, where the coordinates of u are 0 and u, and the coordinates of w are 6 and w. So let's look at v and w. So rise over run, we have the difference in our y coordinates, which is w minus 4, divided by the difference in our x coordinates, which is 6 minus 2. And now I know that that is going to equal 8. So 6 minus 2 is 4, so we end up with w minus 4 equals, and then cross multiply, we get 8 times 4, which is 32. And so w is going to equal 36. Finally, we can solve for u, same method. So let's find the difference in our y coordinates. So we have 4 minus u, all divided by the difference in our x coordinates, which is 2 minus 0, is equal to the slope, which is 8. So we get 4 minus u is equal to 8 times 2, which is 16. Or solving for u, we get u to be equal to negative 12. And those are our two pairs for u and w.